Hey guys, here we are at problems 5 through 8 from our review. So here we're trying to do pretty much the same thing where we're trying to write our equation in slope-intercept form. Again, that's that y equals mx plus b. And this time though, what's a little bit different is that we're given our two coordinates. And you recall from class that this is your x1, y1 and your x2, y2. And so pretty much every single time you're given two coordinates, I mean, it's not 100% of the time, but a lot of the time when you're given two coordinates, you're going to first try and find out what is that slope between those 2 points. Geometry talks about some other stuff, but for us right now, and especially in a lot of algebra, when you're given 2 points like this, you're going to be finding out what is your slope. And if you recall, our slope formula comes out to be m equals y2 minus y1 all over our x2 minus x1. Okay. And so now what we're going to go ahead and do is place our values in where they appropriately belong. So for our y2, we have a value of 1. So we're going to go ahead and place 1 in there, minus our y1. In this case, we see that it is negative 5. All over our x2. In this case, we see that x2 is negative 1 minus from the slope formula. Our x1, in this case, we see that that is 0. So now that we have correctly placed our values in, we're going to go ahead and simplify this. So when we're taking the opposite of negative 5, just looking at the numerator for right now, when we're trying to take the opposite of negative 5, really we're adding 5 there. And as a result, we end up then with a slope that's equal to 6, because 1 plus 5 is 6, over, on the bottom, negative 1 minus 0. Well, if you owe $1 and then you take away nothing, then you're still left with that owing of $1. So now we have our slope. Let's simplify that just a little bit further. M equals 6 divided by negative 1 comes out to be negative 6. So now that we have our slope, what we're going to go ahead and do is pretty much do what we were doing for questions 1 through 4. Now we have a slope, and we actually have 2 points to choose from. Remember from class, we talked about the helpful strategy that you kind of want to steer for steer for points that if they have a 0, wonderful, use that. And here we actually see a coordinate that they give us that it does have that 0. And as a result, you can do your y equals mx plus b. I'm going to go ahead and show the algebra. There's actually a slightly quicker way too in class, but that we talked about in class, but I'm going to go ahead and show the algebra just for the sake of like consistency among all these problems. So you have your y value in this case, negative 5, equals our m value that we just found, negative 6, times our x value 0 plus some b. Again, all we're doing is taking our point, this guy, taking our slope, this guy, and plugging them into m, x, and y for their appropriate values. So that's why the negative 5 went in its location, the m, negative 6 went in its spot, and the x, 0 went in its correct spot. The only thing we don't know yet is our b value. Well, we end up with negative 5 equals negative 6 times 0 is 0 plus some b. And that's the advantage with kind of using those values that have 0. Things cancel out, nice and easier. And as a result, then we have negative 5 equals just b. So to rewrite our line, we would end up then with y equals our slope that we just found, negative 6, x plus negative 5. Or if you want, you could just do minus 5. That's fine too. All right. Now, the quicker way is just to recognize, oh, I'm actually given my y-intercept right here. So if you can spot that and identify that, great. but you do have to still find your slope. And so, like, what I mean by that is some of this, like, blue stuff that you just saw, you can kind of bypass, but that's if you get lucky and they give you that y-intercept. Most of the time they don't, as you can kind of see through examples 6, 7, and 8. They don't really give us that y-intercept value. So that's why I wanted to run through this algebra right here. Okay. Now, if we're looking at problem number 6, we're just going to pretty much rinse and repeat what we just did for problem number 5. Okay. So we have our x comma y and another x comma y. Again, we're using our slope-intercept form, which is y equals mx plus b. And usually we like to identify which points are which. Historically, a lot of my students, they, again, like to have the first point just be x1, y1, and then the second point be x2, y2. So you can switch those around. Again, we talked about in class why you can do that, but for us right now, we'll just stick with that. Now, we're going to go ahead and first find our slope. M is equal to y2 minus y1 all over x2 minus x1. Plugging in our values where they appropriately belong, we have our y2, in this case it's 5, minus our y1 is negative 5, all over. Our x2 is 3, minus our x1 is 1. Okay. Simplifying things further, we end up with 5 minus negative 5. Really, when we see that double negative like that, we're going to go ahead and add and end up then with 5 plus 5 is 10 on top. Whereas on the bottom, we have 3 minus 1, which comes out to be 2. And so, simplifying things further, we see that our m comes out to be 5. 10 divided by 2 comes out to be 5. Next up, we're going to go ahead and pick a coordinate and utilize our slope that we just found. Now, again, we talked about that strategy where if you can try to pick values that are mostly positive, hey, that's great. That usually helps people out avoid some negative issues. And we actually have that here. So we'll go ahead and use 3, 5. Now, placing our values into y equals mx plus b, we have our y value. In this case, it is 5. Equals our m value. In this case, we just found it to be 5, right there, times our x value, which is 3, plus some b that we don't know. Simplifying this further, we end up with 5 equals 5 times 3 is 15 plus b. And then in order to solve for b and get him by himself, we're going to subtract 15 from both sides. 15 minus 15 comes out to be 0, leaving you with just your b that you want by itself on the right side, equals 5 minus 15 is negative 10. Now that we've found m and we found b, we're going to go ahead and write our equation of the line. So y equals, it looks like 5x minus 10. Again, we just plug them in for our m and our b that we just found, okay? We leave our x and y alone. And in class we talked about y. It's because there's several other points that also work. These are just, what they gave us are just 2 of them that work. But there are many others. Next up, question number 7. We are, again, given 2 coordinates. And we're going to go ahead and just label this guy x1, y1. And this guy x2, y2. And use our slope formula. So m is equal to y2 minus y1 all over x2 minus x1. And then placing our values where they appropriately belong, we end up then with 4 minus our y1, in this case it's 2, all over our x2, in this case we see that it's negative 3, minus, again from the slope formula, our x1, which is negative 4. Now, simplifying things on top, we have 4 minus 2. Well, that's just 2. There, we'll give ourselves some more space. We'll go up here. We end up with 4 minus 2, which is 2. On the bottom, we notice that we have negative 3 minus negative 4. Again, when we see that double negative like that in a row, we are keeping the first guy and changing to positives for the other guys, the positive 4. Okay, so now you really owe 3, but you have 4, which comes out to be regular 1. So our slope in this case comes out to be m equals 2, because 2 divided by 1 is 2. Next, we're going to go ahead and find our equation of the line by finding b. So we have y equals mx plus b, one of the most famed equations of all time. And we have our slope, m, so we can go ahead and plug that in. Now we have to go ahead and use a point. We actually have a choice between these two, negative 4 comma 2 and negative 3 comma 4. And the reason why we have that choice again is they're both on the line. Personally, I like to kind of keep things a little bit on the smaller side. In this case, since all the numbers are pretty close together, it doesn't really matter as much which one we go with, but I think to kind of help ourselves out, let's try this guy right here. So when we go ahead and plug those values in for x and y, our x value in this case is negative 4 plus some b, whereas our y value is regular 2. And now we're going to go ahead and multiply these two values. So we have 2 times negative 4, which is negative 8, plus some b equals 2. And then in order to get b all by himself, we're going to go ahead and add 8 to both sides. Here they cancel, leaving you with b coming out to be equal to 8 plus 2 is 10. So then lastly, we just have to rewrite our equation of the line. So it looks like it comes out to be y equals our slope that we're going to use, 2x plus 10 as our b value. Lastly, we have question number 8. Again, we're going to go ahead and start off by labeling our x1, y1, x2, y2. And our slope formula is m equals y2 minus y1 over x2 minus x1. And now we're going to go ahead and place those values in where they appropriately belong. Again, just trying to find the slope between these two coordinates. So it looks like our y2 value is 3 minus our y1 value is negative 5. You can put it in parentheses or you don't have to. Usually when I'm first teaching that to students, I advise it, but you don't have to. Our x2 is 3 minus our x1 is 4. So there are our values where they appropriately belong. And now let's go ahead and simplify this. When we have 3 minus negative 5, again, when you see that double negative like that in a row, we can go ahead and change that to adding the positive value of 5. So on top now, we really actually have 3 plus 5, and that comes out to be 8. On the bottom, we end up with 3 minus 4. Well, that's negative 1. So it looks like our slope comes out to be m equals negative 8. Taking our slope, now we're going to go ahead and plug that value into our y equals mx plus b. We get to choose a coordinate. You can use 3, 3 or 4, negative 5. It really doesn't matter. But again, most of the time we like to use those positive values. I'm going to go ahead and show the little bit of a harder one just so you can see it with more negative values thrown in there. But most of the time you would want to use this guy. But I'm going to go ahead and choose him for right now just to kind of see the harder situations when you eventually run into those. So for our y value, we notice that it is negative 5 equals our m value we just saw is negative 8. So negative 8 times our x value is 4 from that coordinate plus some b that we don't yet know. And now we're going to go ahead and multiply these two values. So negative 8 times 4 is negative 32 plus some b. And on the left side, we still have that negative 5. In order to get b all by himself, we're going to go ahead and add 32 to both sides. So negative 32 cancels out with regular 32, leaving us with our b equals negative 5 plus 32 comes out to be 27. So there is our b value. And again, we want to rewrite our equation of the lines. We end up with y equals negative 8x plus 27. So there's our equation of the line for question number 8, and there it is for number 7. Again, though, guys, that is our review for questions 5 through 8, just writing an equation in slope-intercept form given 2 coordinates.